Hello, I'm Marissa Englert, and for my final project I worked on trip optimization. For this presentation, I'll introduce my project, tell you the objective of my optimization, talk about the methods I used, tell you about the results of my work, and discuss some options for the future. When I began my project, I wanted to optimize a multi-country trip with destinations throughout Europe. As I moved forward, I began to add some specifics to the problem. I've decided that I want to visit 6 countries over a 31-day span. To get to these cities, I wanted to have 3 options for transport: plane, train, or bus. I've set up 3 objectives for the project. I want to be able to decide what mode of transportation will be used to travel between the cities based on the price per kilometer for each type. I also want to decide in which order the cities will be visited based on the mode of transportation and the distance. Finally, I want to determine the number of days that I will spend in each city based on the hotel price per night. The overall goal of my project is to minimize the price of the trip. To work on the first and second objectives, I set up a function to relate the distance between cities, the price per kilometer depending on the mode of transport, and the overall transportation price. This is a variation on the traveling salesman problem. The goal of the traveling salesman problem is to find the shortest distance to travel visiting each city once and returning to the initial city in between. My situation is similar, except instead of focusing on the distance between cities, I am looking at the price necessary to travel. I also don't want to return to the original city between legs. Using MATLAB and a genetic algorithm, the cheapest mode of transportation between the cities was chosen, and the best order in which to visit was determined based on the prices of transport. My third objective started with a similar function that relates the average price of hotel per night and the number of days spent in the city with the total price for the lodging during the trip. I also set up some constraints to make the whole thing a bit more interesting. I decided I wanted the entire thing to last 31 days, I wanted to be in Edinburgh for at least 4 days, and all other cities for at least 3. I also decided I wanted to stay in Barcelona at least as long as I was in Berlin, and wanted to stay in Venice at least as long as I was in Salzburg. Because of the linear nature of this function, it was possible to utilize linear programming to determine the number of days in each city. Incorporating the equality and inequality constraints provided an optimum plan of travel to minimize the overall price of lodging. Here are the results of my optimization. As you can see, for the optimal trip, I should stay in Edinburgh for 4 days before traveling to Amsterdam by plane and staying for 9 days. Then I should travel by train to Berlin, where I will stay for 3 days. From there, I should travel to Salzburg by train and stay there for 3 days, moving on after that to Venice by bus for another 9 days. Finally, I should end my trip in Barcelona by traveling by bus and stay for my final 3 days. Using this plan for the trip, the overall cost will be $4,518.70. However, this price is a very much approximation as the cost for lodging and transport changes very regularly. However, this optimization project gives a basic idea of what type of trip is possible in the given time range and price. These concepts and methods can be used and modified for any type of travel situation. Depending on preferences, variables being considered can be changed. This allows for a lot of customization. Future work can also include the incorporation of more data, like peak season prices, more modes of transportation, more countries, and more constraints. With more accurate data for pricing, a closer estimation of the overall cost could be determined. There are a lot of applications for this type of optimization work. Thank you.